Okay, today let's talk about Leetcode 3342. It is the last problem in contest 422. First part is the description. We are given a string. Any character in this string is a number from 0 to 8. For example, 2, 5, 3. There is a definition about balanced string. That means the sum of the digits on the even position is equal with sum of the digits on the odd position. Let's take this as an example. The position 1, 2, 3. So the even, the sum of the even will be 2. That means 5. For the odd, some of them will be 2 and 3. Some of them will be 5. So this is a balanced string. The problem is how many kinds of permutation we can resort this string and become it into a balanced string. How many permutations? Permutation, we can make it as a balanced string. This is the definition about, this is description about this problem. Next part, let's talk about solution. Actually, we need to use dynamic programming to solve this problem. For the dynamic programming context, it's very hard, but it always need 2 steps to solve this, to use this method. First is how to define DP array. This is the first step to use DP method, and the second one will be how to update it. Yeah, only two problems to solve the dynamic programming problem. For this specific problem, the limitation is very low. For example, every element is from 1 to 9, and the length is less than 80. This is very small, so we can use a multi-dimension DP array. Multi-dimension. How to define the dimension? This is about the limitation about this problem. What there are how many? Let's talk about the limitation more specifically. First will be for every number from 0 to 9, amount of even position. This is kind of the limitation, because there are only half of the length for even positions. So this will be the first limitation about this problem. We can use it as a dimension of the DP array. Meanwhile, the odd position also can be a dimension. The second can be the sum of the value, because we must need sum of the digit as half of the sum of the whole array. So this will be another limitation. In addition, we also need to update the DP array. That means we can update it from 0 to 9, step 1 by 1. So we also need another dimension for the 0 to 9. So this here is the result, how to define the DP array. DP first dimension can be 10. That means let's put the result. Let's put the dimension first. Actually, first is the for the 10. That means from 0 to 9, we can update it from 0 to 9. That means the index of the array. For the 41, that means amount. We use another color. Amount of even position till index. This index means the first dimension of this array. So 41 means amount of even positions. We already put number into them till index, till the first dimension. This is the definition about the second dimension. So for the third one, it's very similar. That means amount of odd position. This is the definition about the third dimension. For the last one will be the 41. That means sum of even positions. We don't need a odd position, some of the odd position, because we can subtract some of the first index value into the current one, into the even one, so we will get the old. So we don't need some of the odd positions. There are also be a value. So for the value, it will be amount or permutation. This is the answer. Okay, this is how to define the dynamic programming array. We can update it from 1 to 9 every time, and every dimension have its specific meaning. So this is the first step. That means we already define the DP array. The next step will how to solve it. How to update. Let me how to update it. For the dpijkz, we can update. For every value at GKZ, we need to add I plus 1 into 8. For the I plus 1, we can calculate before we can calculate the count of I plus 1 in the string, in the original string in the past. So we can use it at this time. More specifically, we can add from 0, 1, 2, 3, or most will be count ms1 even into dp value. We can add at most will be count n plus 1, because this is the maximum possible possible count of n plus 1. After updated, the value we want to update in the array will be I plus 1. This is how we update. And G will be the amount of even position, so G will become, we made it x, so G will be x. And for the key will be the amount of odd positions, so key minus count I plus 1 minus x. So this is how many we need to add to key. How many with key? For the last member Z, we can update it. Z add how many sum of the value for I plus 1. It will be I plus 1 is the value and the amount will be X. So this is how many we need to add to Z. So for every value in the original dimension IGKZ, we can update the I plus 1, G plus X, and K plus count M minus 1 minus X and Z minus this kind of thing. So this is how we update. This is how we update it. In addition, how many times, how many kinds of situation for the permutation we need to update it. That means update value. Updated value. This is another detail about how to update the DP array. For every time, we can calculate the current sum of count I. After that, we will know how many positions we have for the last numbers. So it will be length minus current sum. It will be how many positions we have till this index. So if we want to choose X numbers, X positions from the all positions, so this is we need to use the function C. That means we need to choose X positions. Actually, this is for even positions. So we need to choose X positions from length minus. We need to choose X elements from these elements. C function means how many kinds of method we can choose, how many kinds of results we can choose. We can choose X elements from this value. We can use the C. This C means C for the even. For even. Another, we also need to say count I plus 1 minus X and length minus current sum for odd. So this is for odd. So this is how many kinds of permutation how many kinds of situation we can choose. We can choose for odd position, odd numbers. So for every update, we will multiply the C1, that means C1, C2, multiply C2, and update. This is how many times we need to update to the new value. That means for every times update, we need to add C1 multiply C2. The original value, original kinds of situation, DP. How to write this? Actually, it will be DP current multiply C1 multiply C2, and the new DP value add to the new DP new value. This is how we do this. For the code, we need to write DP new plus equal DP current multiply C1 multiply C2. This is the specific code about to update the array. Okay, this is our solution about this problem. Next part, let's talk about complexity. Actually, the time complexity is very interesting. For the dimension of the array, it will be 10 plus 40 plus 40 plus 400. This is the most maximum possible sum of the value, sum of even position. This is the all numbers of value in the DP array. Every time we need to update it, we use we need to travel the every possible value. So for every time, we also need to at most 40 times to update one value. So this will be the time complexity. After calculate it, we will know it will be 200 million. This is very high. If it is so high time complexity, it will time liquid exceed, but it also can acceptable because we will use some cut strategy. When we update the value of dynamic programming, this is also a common method to reduce the consuming time. That means we need to use some cost strategy. For example, if the number of the even position or odd position is larger than half of the length of the string, it is definitely not possible, so we don't need to update it anymore in the next few steps. In addition, if the sum of the even digits is larger than half of the sum of the string, we also don't need to update it anymore. So this is about card strategy. Yeah. This is the time complexity. For the space, time complexity is definitely will be 1 multiply 40 multiply 40 multiply 400. So it will be 6 million. Yeah, this is definitely acceptable. Okay, this is all about this problem, about the solution and explanation. If you have any confusion, welcome to submit a comment. Thanks for your watching.